So, good afternoon, everyone. Today we are going to discuss BSc third year, semester 5th, Geology, elective A, Mineral Exploration and Mineral Economics paper. And today is we are discussing about Unit 2 and Unit 3, Geological Exploration 1, Physiographic and Mineralogical Guides, and Unit 3, Geological Exploration 2, Stratigraphic, Lithological and Structural Guides. Uh, and yesterday we have discussed Unit 1, Principles and Strategies of Mineral Exploration. Okay, and today we are going to complete this Unit 2 and 3. So it is the black one, Mineral Exploration 1. Okay. So unit 1 to 3, it comes under black one, mineral exploration 1. Okay. And introduction. When we talk about the mineral exploration, geological and geological exploration 2, we'll discuss about the physiographic mineralogical guides and stratigraphy, lithological, structural guides. So geological guides like indicators for mineral deposits found at the earth surface. Geological guides are indicators for mineral deposits found at the earth surface. And here three types of geological guides we can observe. One is physiographic and mineralogical guides. The second one is stratigraphic and lithological guides. Okay, and third one is structural guides. These three are the geological guides. Okay, these three are the comes under the geological guides. One is physiographic and mineralogical guides, stratigraphic and lithological guides, and structural guides. And physiographic guides are these are based on geomorphic features, and it provides direct or indirect evidence for ore presence. Physiographic guides are based on geomorphic features, and it provides the direct or indirect evidence for the ore presence. Okay, and whereas mineralogical guides are observed in primary and secondary ore deposits. Primary and secondary ore deposits. Physiographic guides. Physiographic guides direct evidence, indirect evidence, and historical evidence. It has divided into three again. Physiographic guides are divided into three types again: direct evidence, indirect evidence, and historical evidence. So, geological guides are divided into three types, that is physiographic and mineralogical guides, stratigraphy and lithological guides, structural guides. Whereas physiographic guides are based on geomorphic features, provide direct or indirect evidence for ore presence, and mineralogical guides observed in primary and secondary ore deposits. Okay. In physiographic guides, it has divided into three. One is direct evidence, indirect evidence, historical evidence. So direct evidence is the immediate indications from surface ore bodies. So direct evidence is immediate indications from surface ore bodies. And indirect evidence is features like fault scraps, hugbacks, and crustas. These are the hugbacks and crustas are the indirect evidence for the ore deposits. Okay, and historical evidences are helps to identify conditions for ore accumulation or enrichment. Direct evidence, immediate indications from surface ore bodies. Indirect evidences features like fault scraps, backs, and crustas. And historical evidences helps to identify conditions for ore accumulation or enrichment. Topography as a guide. Eminence and in topographic guides, eminences and depressions, eminences and depressions are the elevations or depressions indicate ore presence. And example, hematite iron ore deposits form hills in India. Salem district magnetite ore forms resistance hilltops. Okay. Two Indian examples here we can observe. One is hematite iron ore deposits from hills in India, and Salem district magnetite ore forms resistance hilltops. These are the topographical guides of the mineral exploration geological guides. Okay. And whereas in oxidational substances, depressions formed by ore body oxidation seen in Bisbee, Arizona, indicating copper deposits. These are the locations where the depressions formed by ore body oxidation seen in Bisbee or Arizona area indicating copper deposits. These are the oxidation subsidence. Okay, na? Subsidences. And these are the depressions or subsidences formed by the ore body oxidation. Due to the ore body oxidation, these depressions are formed. Example in copper deposits of Arizona and Bisbee. Okay, Bisbee area. Whereas of ore deposits are physiographic environment of ore deposits are geomorphological features like canyons, pediments, placers, residual ores, and supergen enrichment zones. These are the features of geomorphological guides. Okay. In top, you have discussed about topographical guides, and in physiographic environment or deposits, we are discussing about geomorphological features. Geomorphological features like canyons, pediments, placers, residual ores, and supergene enrichment zones. In canyons are ore bodies are often found in deep canyons, as in Sierra Madre, 1 minute, Mexico, where silver ores are exposed to. This is the example from Mexico, where silver ores are exposed to, like canyons. Ore bodies are often found in deep canyons, as in Sierra Madre, Mexico, where silver ore deposits are exposed. You can remember or you can write down these best examples from the worldwide or Indian. Okay. So the canyons is the best example located in the Mexico area. And here this Arizona is the copper deposits, indicating as the oxidation subsidences. And geomorphological features like canyons, pediments, placers, residual ores, super enrichment zones. So pediments in geomorphological features, we have discussed about canyons. Now we are going to discuss about the pediments. Pediments, the rock floored plains are favorable for vein deposits. Pediments are favorable plains or rock floored plains are favorable for vein deposits. So these are the canyons and pediments which are comes from the geomorphological features. These geomorphological features are the guides of physiographic environment of ore deposits. Okay, and in physiography, in relation to the placer deposits, so we have discussed about canyons and pediments. Now we are discussing about placer deposits. The physiographic in relation to the placer deposits are favorable conditions for placer formations like preparation, deep weathering. Next, concentration, shortening by streams, preservation, covering by younger deposits. Yes, after weathering and shortening by the streams, the deposits are placer deposits are covered by younger deposits. Okay, younger deposits. These are the procedure for the formation of placer deposits. First, in placer deposits, what will happen? Placer deposits first preparation means deep weathering, and next concentration shortening by streams. These weathering deposits or weathering sediments are concentrated by the shortening process of the streams. Then these sediments or whatever weathering products, preservation will be there. In preservation, it is covering by young deposits. These earlier preserves or placer deposits are covered by younger deposit. This is the process of the placer deposits formation. Example, upliftment and erosion uncover gold placers in Arizona, USA. If you able to remember these words or this area, you can write the entire process of the placer deposits. Here we have discussed about the placer deposits, how they will form. So preparation will be there, concentration will be there, and preservation will be there. So example is upliftment and erosion uncovered gold placers in Arizona, USA. And next we'll discuss about the pay streaks in placer deposits. So here in pay streaks in placer deposits, ore locus will be there. Pay streaks like ore locus stream channels are the primary locations of ore. What these stream channels are the primary locations of ore. Okay. And whereas in pay streaks, ore accumulates where stream velocity decreases in an area of flatter gradients or broad valleys. What will happen in placer deposits? Pay streaks are or ore accumulates where stream velocity decreases in areas of flatter gradients or broad valleys. So these are the different type of placer deposits formations. One is favorable condition for placer formation is preparation, concentration, and preservation. And pay streaks in placer deposits is about ore accumulates where stream velocity decreases in areas of flatter gradient or broad valleys. Okay. So the ore accumulates in the broad valleys or in a flatter gradients in the decreased stream velocity areas. Okay. So till now we have discussed about the introduction, geological guides, types of geological guides, okay, and physiograph guides, mineralogical guides. In physiograph guides, direct evidence, indirect evidence, historical evidence, and topography as a guide is eminence and depressions and oxidational subsidences, physiographic environment of ore deposits, geomorphological features, canons, pediments, players, and what are the different type of players and where it will form and how they will form, we have discussed. And physiography in relation to oxidation and residual ores. Physiographical guides is related to the oxidation and residual ores. Ore types. For example, nickel sulfates, bauxite, manganese, and lateritic iron ores. These are the ore types related to the oxidation and residual ores. So, based on oxidation and residual ores, we have divided ores. So, nickel sulfates, bauxite, manganese, and laterite ores are and weathering. Formation of these ores occurs on erosion of surfaces with deep weathering under tropical climates. So, oxidation ore deposits or residual ore deposits are formed. Formation of these ores occurs on erosion surface with deep weathering under tropical forms. These oxidation and residual ore deposits are formed due to the deep weathering, due to the deep weathering under the tropical climate conditions. So due to the weathering or deep weathering or tropical climate conditions, these oxidation and residual ores are formed. For example, nickel sulfates, bauxite, manganese, and laterite. These are the oxidation and residual type of ore deposits. Okay, due to the deep weathering and tropical climates. Examples are bauxite in Madhya Pradesh. See here, what are the physiography in relation to the oxidation and residual ores? So oxidation, due to the oxidation and residual ores, and it has formed due to the deep weathering and tropical climates. And then what are the types, ore types? Nickel sulfate, bauxite, manganese, and laterite. These are the oxidation and residual ores formed because of due to the deep weathering and tropical climates. Deep weathering under the tropical climates. These nickel sulfate, bauxite, manganese, and laterite ores are formed. And best examples are bauxite in Madhya Pradesh, Maharashtra, and manganese in southern India. So bauxite in Madhya Pradesh and Maharashtra and manganese in southern India or South India. Okay. These are the best examples of the oxidation and residual ore deposits. How they form, where they form, okay, and what is the examples we have discussed here. And supergen sulfides. Supergen sulfides are conditions for enrichment. Like copper or silver ore oxidize at the surface, leaching below the water table. Supergen sulfates formed due to the leaching below the water table, okay, or oxidized at the surface of the earth or leaching below the water table. So, like copper and silver ores are formed as supergen sulfides. So, for example, copper or silver ores oxidized at the copper or silver ores oxidized at the surface or leaching below the water table. This is the conditions for enrichment of copper and silver deposits, copper and silver ore. Okay. And importance of physiographic history is enrichment occurs when erosion gradually Enrichment occurs when erosion gradually lowers the water table, enhancing ore deposits. Enrichment occurs when erosion gradually lowers the water table, enhancing ore deposits. Enrichment occurs when erosion gradually lowers the water table, enhancing ore deposition. Okay. Supergen sulfides, conditions for enrichment, copper ore, silver ores. Okay. So these are the supergen sulfide ore deposit formation. Okay. Condition for enrichment and importance of physiographic history we have discussed here. And in next slide, these are the some of the images or samples of the field evidences of the mineralization. Okay. Sulfide bearing rocks A and B. Okay. And arrow shows the mineralized portions. Here you can observe this is the area where mineralization occurred. And this is the area where mineralization occurred. Okay. And here also azurite in blue color. This is the blue color shade is the azurite. This is the azurite. Blue color is azurite. This is also azurite. Okay. And this is also malachite, green stains. This is the green stains in the malachite ore deposit. These are the green stains observed in the malachite, malachite ore deposit. And these are the blue stains or blue color formation. This is the azurite formation. Okay. And here you can observe this is the mineralization portion of the ore, different type of ore and sulfide bearing rocks. Okay. And mineralogical guides. Till now we have discussed the geological guides. In geological guides, we have discussed the type of geological guides, physiographic, stratigraphic, structural, okay, and physiographic guides, physiographic, direct, indirect, and historical evidences, topographic guides as examples and depression, eminences and depressions, examples and oxidation substances, physiographic environment or ore deposits, geomorphological features, canons, pediments, pleasure deposits and different type of the pleasure deposits we have discussed. Okay. And physiography in relation to oxidation and residual difference. And what are the oxidation and residual ore deposits? And where they form, how they form, and what are the examples of the Indian. Okay. And supergen sulfides, how they form, what are the best examples we have discussed, like copper, silver, oxidation at the surface or leaching below the water table, and importance of the physiographic history we have discussed. And these are the different type of the sulfate bearing rocks and azurite, malachite. These are the mineral mineral occurrence portions of the mineral occurred, okay, or mineral formed. So now we are going to discuss about mineral guides, mineralogical guides. Till now we have discussed geological guides. In mineralogical guides, role of minerals, variations, rock alteration as a guide, mineralogical changes, alteration minerals, and indicator of minerals we'll discuss. Okay. And mineral zone as a guide, zoning types, zoning process, oxidation products as a guide, like gosons, we'll discuss, and boxwork structure of limonite, signetate and epigenetic deposits, syngenetic and epigenetic deposits we'll discuss, and epigenetic deposits, com competence versus incompetent formations, structural guides we'll discuss. Okay. In mineralogical guides, in mineral exploration, geological, mineral exploration one, okay, mineral exploration, today we are discussing about the geological exploration, physiographic and mineralogical guides, okay. And the second, geological exploration, stratigraphic, lithological and structural guides. Oh, in mineralogical guides, role of minerals, the presence and relative abundance of certain minerals help locate ore deposits. What will happen here? Okay. The presence and relative abundance of certain minerals. Presence and relative abundance of certain minerals helps the locating of the different type of the ore deposits. So their relative abundance, certain minerals helps the locating the ore deposits. And variations like in vein matter and wall rock, in vein matter and wall rock, mineralogical differences can form target rings guiding ore search. What will happen? For example, in vein matter and wall rock, mineralogical differences can form target rings guiding or searching. Okay. And whereas in rock alteration as a guide, mineralogical changes occurs due to the influence of mineralizing solutions, and alteration minerals like examples include garnet, amphiboles and pyroxenes, okay, and cerecite, chlorite. These are the alteration minerals. And mineralogical changes occur due to the influence of mineralizing solutions. Due to the influence of mineralization solutions, different type of ore deposits will form. And best examples of the alteration minerals are garnet, amphiboles, pyroxenes, okay, cerecite and chloride. These are the best examples for the alteration of minerals in mineralogical changes. And indicator minerals are those are the alteration minerals, and indicator minerals are serves as prac- practical guides for locating ores. Indicator minerals serves as practical guides for locating ores. Okay, so in mineralogical guides, role of minerals, the presence and relative abundance of certain minerals helps the locating different type of ore deposits, and variations like vein matter, wall rock, mineralogical differences can form target rings and guiding the ore search, and rock alteration as a guide. So rock alteration also one of the guide or indicate for the ore deposits searching or locating. Okay, in mineralogical changes occur due to the influence of mineralizing solutions, and alteration minerals, for example, garnet, amphibolite, pyroxene, and cerecite chlorides are the alteration minerals. Okay, and what are the indicator minerals? These indicator minerals are serves as practical guides for locating the different type of the ore minerals. So for the identification of ore minerals, indicator minerals and alteration minerals will help the mineralogical guides. Will help as the mineralogical guides. Alteration of minerals and indicator of minerals will help the guides as a mineralogical. Okay. So mineralogical guides are the one is mineralogical changes, alteration of the minerals and indicator minerals. These indicators are the alteration minerals are helps the identification of the minerals, mineral ores or mineral zones. And next, mineral zoning as a guide. So what is the mineral zoning again? Okay, zoning type. What are the mineral zoning and what are the zoning types? Normally, we'll find zoning types as horizontal zoning type, vertical zoning type, and local or zoning type. Okay, in in mineralogical zoning as a guide, we'll discuss about the zoning types. Those are three types, and we'll discuss about the zoning process. What is the process of the zoning, and what are the types of the zoning? So types are three: horizontal, vertical, local, or zoning. And process is high temperature minerals near the source with low temperature minerals further away. And if you observe the process of the zoning, high temperature minerals are near the source we can find, and with low temperature minerals further away. So this is the process of the zoning, and these are the zoning types. And oxidation products as a guide. Oxidation products as a guide. Gosans. So due to the oxidation of the mineral ore deposits, gosans will occur. Okay, what is the gosan? Gosans oxidized limonite-rich caps overlying sulfide deposits. What is the gosan? Gosan is a oxidized limonite-rich caps overlying sulfide deposits. These are the oxidation products as a guide for the mineralizing or ore deposit zones. Okay. These are comes under the mineral zoning as a guide. Okay. So zoning types are three and zoning process we have discussed. And Gosan is the one of the product oxidation product of the mineral guide. The Gosan is a oxidized limonite rich caps overlying sulfide deposits. These caps are these oxidized caps are these oxidized Gosan caps are we can find in the overlying the sulfate deposits, and top of the sulfate deposits we can find the Gosans. The Gosans are oxidized limonite rich caps which are present in the or above the sulfide deposits. Okay, and true versus false Gosans. So here we have divided into two types again. One is true and false. Okay, and one is true and second one is false Gosans. Endogenous limonite from iron bearing sulfates. Okay, indigenous limonite from iron bearing sulfates. These are the true Gosans. Whereas false Gosans transported limonite formed from neutralized iron or copper deposits. What are the false Gosans again? Transported limonite formed from neutralized iron or copper deposits. So from iron or copper deposit after neutralization, these transported Gosans will form. So these are the false Gosans because of already they have transported, okay, and they have formed the neutralized iron or copper ore deposits. So that's why we called as a false. So that is not a original place R. Okay. So this is the transported limonite formed. from neutralized iron ore. Already these iron ore coppers are neutralized and transported. Then limonite gosan is formed. That is called as false gosan. Where true gosan is endogenous, okay, endogenous limonite from iron bearing sulfides. And there only it has formed, okay, on the top of the sulfide deposits. That is called as the true gosan. Okay. And boxwork structure of limonite. The different type of the structures are, so we can call as the structural guides for the mineral ore deposits. Okay. And boxwork structure of limonite. Boxwork patterns. What are the boxwork patterns again? Honeycomb or cellular patterns in leached outcrops. In leached outcrops, we can find the patterns like cellular patterns, honeycomb patterns. We will find these are the patterns called as the boxwork patterns, which are help in the mineral exploration or identifying the mineral deposits. Okay, in limonite. Okay, and clues to mineralogy. And these boxwork structures are patterns we have discussed there and clues to the mineralogy. Boxwork structures and color of limonite help identify underlying sulfide minerals. So these boxwork patterns, color, we can mm, use as a identifying underlying sulfide minerals. So if you find boxwork patterns and their color in some zones, we can use as a identifying or indications for the sulfide mineral zones. We can use as a clues to the mineralogy. Boxwork structures and their color of limonite help identify underlying sulfide minerals. So these color and patterns we can use for the identification of the limonite or sulfide mineral uh, ore deposits identification. Whereas stratigraphic and lithological guides. And in stratigraphic and lithological guides, it has divided into one is stratigraphic guides and lithological guides. Then stratigraphic guides are ore deposits associated with the specific sedimentary beds. Okay, stratigraphic guides are ore deposits associated with specific sedimentary beds. Then only we can call as the stratigraphic guides for the mineral exploration. And what about lithological guides? These lithological guides used for ore deposits in igneous or volcanic rocks. So lithological guides are used for ore deposit identification in igneous in volcanic rocks. Like, for example, chromite in ultra basic intrusions. So, stratigraphic and lithological guides are identified for different type of ore deposits. For example, stratigraphic guides are ore deposited associated with the specific sedimentary rock beds. Okay. But whereas lithological guides are used for the igneous or volcanic rocks ore deposits, associated ore deposits like chromite in ultra basic intrusions. So there is a particular purpose for the lithological and stratigraphic guides. Okay. And example, hematite in iron ore series India and chromite in Johatu Singbam. Okay, Johatu Singbam. These are the best examples from the India. Okay, and these are the stratigraphic and lithological guides. One is stratigraphic guides are ore deposits associated with the specific sedimentary beds. Lithological guides are the used for the ore deposit identifying in the igneous or volcanic rocks. Example is chromatin ultra basic intrusion. This is the example for best example for the lithological guides. And when ore deposits are associated with the sedimentary beds, they can call as the stratigraph guides for the mineral exploration. Okay. Best examples are hematite in iron ore and chromite in Johor to Singbum. Okay, these are the examples of the stratigraph and lithological guides. And again, we'll discuss about the syngenetic versus epigenetic deposit. What is the syngenetic and epigenetic deposits again? So, and exploration focus and syngenetic deposits exploration. This These we are going to discuss in the present slide. The syngenetic ore forms concurrently with the rock, okay? And epigenetic ore forms later are replacing or filling fractures in the rock. See, syngenetic ore forms concurrently with the rock. The rock formation only, with the rock formation only, syngenetic ore deposits will form. But whereas epigenetic ores are forms later or replacement or filling of particular gaps or fractures in the rock. So when the rock formation, during the rock formation only, ore forms, those are called syngenetic. Whereas epigenetic ores are formed later or replacement or filling the structure, different type of structures of the which are present in the host rock. Okay. And exploration focus. So what is the syngenetic and epigenetic exploration focus? Syngenetic deposits are easier to explore due to their regularity, while epigenetic deposits are more complex because the epigenetic deposits are more complex because of their latter formation or replacing or filling of the different type of gaps or fractures. But syngenetic are uh, more easier because of their regularity, their formation time, their location time with the host rock. Okay. And syngenetic deposits exploration. So how we will do syngenetic deposit exploration? And okay, ores as integral part of rock. So what happened is syngenetic process, it indicates the ore rock with the host rock only. Ore deposit with the host rock only. So ore as a integral part of rock. Ore is confined to a specific rock formation. So ore with itself present in the rock formation. But whereas epigenetic, it will form after the replacing or filling of the fractures. Okay. And easier exploration because stratigraphy sequence and structure predict ore locations. And examples is chromite in mafic rocks. For syngenetic deposit exploration, it is very easy comparing to the epigenetic ore deposit identification or exploration because stratigraphic sequence and structure predict ore locations and their ore confined to the specific rock formation. Okay, because of these regularities, the syngenetic ore deposit formation is more easier than the epigenetic ore formations. And best example is chromite in mafic rocks. Okay, these are the best example for syngenetic deposits exploration. Okay, epigenetic deposit exploration. Ore introduced later. So as per our definition or as per our previous slide discussion, epigenetic deposits are formed later the rock formation. So ore introduced later, itself indicating the ore introduced into fractures, veins or beds. So these are called as the epigenetic. Try to remember or write these keywords. Epigenetic deposits are over introduced later. Exploration complexity. What I have highlighted in the or bolded in the these presentation in these slides. Just to try to remember those words, you can write the theory exam easily. So ore introduced later, ore introduced into fractures, veins, or beds. So that's why it is called as the epigenetic deposit. So exploration complexity. Is there any exploration easier or complexity? Because of epigenetic deposits requires detailed study of fractures, yes, and shear zones and other controlling factors. So we have to, this is not that much easy to explore the syngenetic deposit because of their complexity, like fractures, shear zones, and other controlling factors we have to study in detail. Okay. So there is a requirement for detailed study of fractures, shear zones, and other controlling factors. That's why epigenetic deposits exploration is more complexity. So comparing to the syngenetic deposits and competent and versus incompetent formations. And what are the competent and incompetent rocks and our localization? This we'll discuss in the present and next slides. And competent rocks, strong, break in brittle manner. These are the competent rocks. Example, quartzite. And incompetent rocks are weak, deform, plastically, and example, shields, limestones. These are the incompetent rocks. And competents are quartzite, okay? And incompetent is a weak. So competent is a strong and incompetent is a weak rocks, okay? And a competent example is quartzite, and incompetent rocks example is limestone. It is weak, deformed, plastically, okay? And ore localization. So what is the competent and incompetent formations and their ore localization? Competent rocks often form better host for ore due to their fracturing nature. So comparing to the incompetent rocks, competent rocks are often form better hosts for ore due to their fracturing nature. So fracturing nature, because of fracturing nature, the host, okay, competent rocks are often formed better host for, and it act like a better host for ore deposit, okay, due to their fracturing nature. So fracturing nature is the main property of these competent rocks because of their strong and break in brittle manner. So because of these properties, those are often better for hosts. Okay. And structure, what are the structural guides? Okay. The structural guides are divided into fractures and faults, vein patterns. Okay, what are the fractures and faults? Act as a factors and faults act as a channels for pore bearing fluids. Okay, for example, pore bearing fluids are there. So, is there any fractures or faults or any gaps? There only these fluids are will settle or solidify. So, because of this nature, fractures and faults act as a channels for ore-bearing fluids. So we find these ore-bearing fluids in sorry, act as a channels. Okay, in these channels only we'll find the ore-bearing fluids. Whereas vein patterns, understanding vein patterns is key for predicting ore deposition. So vein deposits indicates the prediction or key for the predicting ore deposition. Or understanding or predicting ore deposition is the key. Key is the vein patterns. Okay. Example, an echelon and a sigmoid and or stelline structure guide or core search. These are the examples from the global global locations, different type of global locations for the fractures and falls and vein pattern as a structural guides. Okay, this is the this is the our mineral exploration one, unit 1 to 3, that is principles and strategies of mineral exploration, geological exploration 1, physiographic, mineralogical guides, geological exploration, stratigraphic, lithological and structural guides. So these we have covered in the our third presentation or third class. Okay. Elective A, mineral exploration, mineral economics paper. Thank you.